Thank you very much, Harv. And as just been mentioned, we're sort of focusing on the innovation part of the journey today, and we're starting with science and technology, and it's a real treat to be able to welcome to the stage Alex van Someren, who is the Chief Scientific Advisor for National Security. I think you probably will not find a bio. I couldn't find a bio in the brochure that we've provided for you, but there is one online if you want to look at it. But the key points are long-time experience with venture capitalism and entrepreneurialism, particularly focused on tech startups. As the Chief Scientific Advisor, he's responsible for providing independent scientific advice on national security issues and working with the other Chief Scientific Advisors to address cross-government, cross-departmental issues. Alex, it's a real pleasure to be able to welcome you to the stage, and we look forward to hearing what you have to say.
Thank you, Mike. Good morning, everybody. And I appreciate the opportunity to be speaking to you this morning. This is a different domain to my usual audience, and it's great to be able to have the chance to give you some thoughts about how we can work across the community to bring science and technology to support your needs. As you heard from Mark, the background to my role is that I'm historically an entrepreneur and a venture capital investor, so I've been building technology products, both in electronics and semiconductors and in software for longer than I care to remember now. And I was lucky enough to become appointed to the position of Chief Scientific Advisor for National Security last July. I principally respond to the demands of the agency heads and to Sir Patrick Vallance, the GCSA. And so in that role, I rejoice in the particular challenge that I am to adapt James Corden's rewriting of a famous play, I Am One Man with Four Governors. And that certainly presents some interesting challenges, not least to good use of my time and prioritization of my skills. The community that I will support in national security, of course, doesn't spend a great deal of time publicizing its activities. And I'm speaking to you today at an official classification, so I'm not able to go into a huge amount of detail about our day-to-day work. But what I wanted to speak to you about, to the theme of our question here, is how the work that we do in science technology can help to support the entire community in the exploitation of space for the benefit of national security. And I think we need to think about a pretty wide interpretation of the concept of national security when we think about that, not just about the audience that I spend most of my time with. So, when we think about the challenges of the space environment, we think about the complexity of space systems. The devices that we're actually placing into orbit, the satellites, a relatively short word containing a great number of complex and sophisticated concepts. Then the supporting infrastructure, the ground segment, the communications, the mission management, and the data processing, all themselves discretely also complex systems. So a real systems of systems challenge here to be able to deliver the exquisite capabilities that we ultimately require in space. And I think considering and breaking down the complexity of that challenge into some of its constituent parts starts to reveal why the evolution of technology and the contribution of science and research is so important. So I want to say a bit more about what we can do as a collaborative community to try to ensure that we bring together all of the requisite skills and to advance not only academic research for the sake of understanding things, but also to deliver a direct benefit to us in supporting our missions. Of course, these systems, once they're launched, they're gone. And so the engineering required to deliver that kind of reliability and resilience in such a hostile environment is some of the most sophisticated engineering that we're capable of doing. And so, again, the contribution of the academic research community to be able to bring us cutting-edge capabilities and to exploit some of these features in ways that historically have been in the laboratory and now need to be rolled out in the field really quickly. That kind of pipeline to pull things through into the mission is something that I think we actually find quite hard within the government sector. And so one of my focuses is to try to ensure that we speed up the journey of getting technology pulled through and successfully exploited in the mission. And of course, when we think about the next generation in space terms, the next generation may be 5 or 10 years away. And so the cycle time is relatively long, and the challenge of us ensuring that we actually anticipate our future requirements well in advance and we're able to deliver what will be the required cutting edge technology is also one of the sort of central challenges of working in this domain. So I think the UK doesn't have all of the capabilities that it would like to have within its sovereign environment. There are some obvious challenges in areas like semiconductors, which are not yet the sort of most significant part of our technological industry in this country. And that's definitely a domain where we've seen a lot of government attention focused in the last few months around the area of having national strategy around semiconductors. And we think of the particular challenges of radiation hardness and the like that are required in the space domain. These are things which we certainly want to ensure we build up our capability on, and I think you'll see some more work on publicly stated in the future. If we look back at how policy has brought us to this point, the integrated review brought us 4 key themes about sustaining strategic advantage through S&T among them. And the importance to the UK of space has been, I think, amply highlighted both politically and practically by the level of investment and engagement as well as leadership that's been shown in this domain. And I find that really encouraging. This isn't just a one-off, an idea which has been thought up and then ultimately allowed to wither. It seems to be something which is actually gathering momentum, and I guess the practical evidence of our presence at this conference today shows that really this is something which we're taking not only seriously, but actually increasingly seriously, and I find that to be very encouraging. The National Space Strategy also tried to call out the importance of protecting and defending our national interests in and through space, ensuring that critical national infrastructure can rely on resilient space technologies, including areas like PNT, and that space allows critical national infrastructure to operate with a lower carbon footprint and with greater resilience. And if we think about the consequential benefits of those ideas, then they're not just about giving us a high-quality offer in space. They're also about how space can bring benefits for wider national security. So thinking like areas like agriculture and health, as much as thinking about the obvious defence and security interests that we might traditionally have thought of. So that background of policy supporting us in the work that we do suggests that there is a really consistent urge to make this an area that the UK is a world leader in. And it's with that environment supporting us that we can then go on and consider what will S&T actually do to deliver results. I'm going to steal a theme from Sherlock Holmes. I'm going to consider the means, the motive, and the opportunity. And I'm turning first to the motive. The recent events that we have around us, the collapse of Afghanistan, the Taliban resurgence, Chinese ambitions and threats to Taiwan, increasing dependence on technology and cyber, and Putin's invasion of Ukraine and nuclear threats, all of those provide a motive environment which suggests that we really need to up our game in terms of capability in space. And we're not starting a moment too soon in the journey that we have already embarked on. One of the chiefs, Jeremy Fleming, said recently something pertinent in Australia. I'll just read it to you verbatim. These all add up to a period of generational upheaval. The economic, societal, and geopolitical consequences are still playing out, and will do so for decades to come. And that's obviously the case in the world of national security too. Here, the threats we face and our approaches to their mitigation are changing rapidly. So we all talk, I think, regularly about how fast the environment, the world we live in, evolves, and technology in particular keeps on evolving at an ever faster pace. But not content with technology itself evolving around us, technology doing things to us, the environment, as we've just seen, is also evolving extremely quickly and in many cases quite unpredictably or unexpectedly. So the upshot of all that is that with the generation time for space evolution being in the multiple years to decades sort of epoch, we can't wait for global events to hit us and then react. We really have to anticipate the future, and we have to act now in order to ensure that UK interests are properly protected and to build on the technology trends, to build on the insights we get through intelligence, and to use those to give us a real head start, because the unpredictability of the environment in which we're operating is really reminding us regularly of how difficult it is to build a single consistent thread through our strategy. And so with that background in mind, we then have to consider, well, what are the means that we have to enable us to defend ourselves better, to secure our communities better, and to exploit space as a platform for wider national security interests? And I think science, of course, is central to the exploitation of space. Indeed, you could argue that science and technology is more or less everything about how space operates. So I wanted to drill in a little bit more into the means by which we actually employ science and technology in space. Satellites have two principal purposes. They tend to either provide sensing capabilities or communication capabilities, and of course, sometimes both. Satellites today come in a wide variety of shapes and sizes, and things the size of the perennial double-decker bus right down to CubeSats mean that the kind of engineering that we're having to do has been undergoing quite significant evolution for many years at the large end of the market, but incredibly rapid evolution just in the last few years at the very small end of the market. And that miniaturization, of course, is incredibly important for the commercialization and for the wider access to space on simple physics grounds. Things which are smaller and have lower mass are easier to launch, to say nothing of usually involving slightly less complexity in the completion and mechanical delivery of the product. Not always so. Science technology can solve these space challenges now by allowing us to act really fast, fail really fast, and learn really fast. And this is a domain in which I think the traditions of the entrepreneurship and startup world that I know something about are really important. We need rapid cycle times. We need to be willing to experiment and fail quickly in order to ensure that we can actually progress sufficiently fast overall. And so launching exquisite products at long intervals cannot any longer really substitute for extremely rapid experimentation at a smaller scale. And this is one of the huge advantages of having a wider commercial and academic community involved in the exploitation of space, that frankly, more mistakes will be made more often by more creative, sometimes younger minds, and the implications of that can then be fed back in a positive feedback loop to help us to evolve our capabilities even more quickly. So it's rather like the Olympics motto, faster, higher, stronger, together. This is a collaborative exercise. We can get benefit from all of those kinds of experiments. We can learn from everybody, and we can use that to enable us to accelerate yet more quickly. In space, we might want to reframe that. Faster, better, smaller together. And the smaller emphasis, I think, is proving to be really productive, despite perhaps some expectation that it might not be so at the beginning. The advent of small launch CubeSats is really proving to be incredibly powerful as an accelerant for the delivery of products into space. Forgive my pun about acceleration. So thinking about each of those individually, first of all, the faster processing of data, shortening the delays in returning data for exploitation, that's really important. And actually, Faster also speaks to the communication speed. Reducing bandwidth so that we can get smaller amounts of data from space back to ground is critically important, because the capacity of our communications channels to deliver that data are not expanding at the rate that the data is expanding by any means. Better in the sense of sensors. Greater resolution, able to detect smaller objects, being able to detect weaker signals, and the sensitivity of sensors is improving very rapidly indeed, and our ability therefore to get higher and higher quality product, whether it's imaging, or whether it's RF spectrum, or whether it's other kinds of capability that we want to sense in space, the capacity of sensors is improving all the time. Smaller, we talked about miniaturization, both of the overall physical systems, but also even things like optics in cameras, aerials, our ability to deliver each of those components and be able to fly them in an affordable and compact and mass minimized way. It really contributes to the ability to have these platforms be effective and particularly to be cost effective faster and faster. And together, this is the probably finest example of a collaborative environment. Not only is the physical domain shared by all the participants in the heavens above us, but also the elements of the system, all of the systems, the system of systems, are all constructed from pieces which no single source, no sovereign nation can in fact deliver by itself. Even if it has the intellectual capability, it may not have the manufacturing capability. Even if it has the manufacturing capability, it may not have the launch capability. Some of the physics of launch mean that sometimes the place on the Earth where one starts is a significant determinant of one's ability to actually get successfully to where one wants to be in space. So it's a really interesting example of an environment in which collaboration is really essential. It's not just sort of fluffy words to describe a desire to work more closely together, although that desire is also, of course, really, really important. So the collaborative development of new space components, the development of new capabilities, the collaboration between national security and defence, where we find common ground between our two domains increasingly, collaboration with industry, where we have systems integrators, we have SMEs, we have now startups, with academia and with international partners, including across the Five Eyes community. These are all essential layers of communication across our systems. And doing that work together also means that we can do something else essential. We can build a different kind of infrastructure, which is about our skills and our ability to grow a generation of talent, which will enable us to scale our space industry in the future. And unless we have those educational opportunities, unless we have the practical chance to get people upskilled. And in space, I think there's an unusual proof point, isn't there, that it's not enough to think you know about a technology. It's the success of flight. It's actually delivering working platforms in space that is the ultimate proof point. And no one is truly qualified unless they've actually had their product fly. That's the threshold which we need to get more and more people across. And if we do that, then we have a skills base that we can not only be proud of, but that we can actually use to ensure our continuing growth and success in the future. So how have we progressed? The UK space industry has become a thing. Those words were not even really meaningful perhaps a decade ago, and yet now we have, beyond the exclusive domain of defence and security, we have an industry which is, by one estimate, into the teens of billions a year in revenue, employing more than 50,000 people. And this summer, if all goes well, we'll see the ultimate proof of one dimension of that, which is successful launch from our own soil. And in that case, with the hoped-for success of Prometheus 2, we'll be able to claim that we've really built up the UK as a place which has all of the elements across the necessary domain. That's been the work of many years, but it's also been something which is really, I think, for many of us actually, caught up remarkably quickly from a position which I hope you'll forgive me for saying is really probably starting from behind. And actually, we've really done a great job, I think, to progress that, to overcome our starting position. And now we need to really capitalize on that as quickly as we possibly can. We've made our own contribution to that from the world that I work in, the national security domain, by establishing an investment activity specifically to support national security investment. It's called, a bit of a mouthful, the National Security Strategic Investment Fund. We call it NSIF for short. And NSIF has made several tactical investments in companies which are specifically about space. The most public of those, Oxford Space Systems, is one example. There are several others which are less well publicized, but we've been really explicit in our desire to help to support the evolving space industry here in the UK and to ensure that we get access, so this is the purpose of the programme, to the kind of technologies which can support our national security mission, but of course also to support the wider ecosystem of developers of space technology and to ensure that we build up a long-lasting and robust UK space industry through our participation, through the participation of those of you working in defence, and through the wider investor community. And it's been very interesting to watch how venture capital investors have decided that space is really a domain they want to invest in. Of course, some celebrity space investors have done a lot to help that. And I think that whatever we may think about the specifics of the individuals or companies concerned, the impact of lowering the cost of launch, widening the accessibility of launch, that's really been tremendous in helping to galvanize the investment community around space. The UK's space investment environment is still relatively modest in scale, but I think that the fact that we are starting to see infrastructure for launch, we're starting to see sovereign early stage startups turning into significant contributors to the global community, those will all help to spin that flywheel faster. And I'm pleased that we're playing our part in the national security community to invest in this, but I'm even more pleased to see that we're getting venture investors who are taking companies all the way to public listings, raising significant amounts of money as a result, and therefore helping us to build that financial infrastructure, which is so important to develop a really meaningful and long-lasting space industry here in the UK. So moving finally then to opportunity. The next generation in space is a few years away, so the opportunity begins today. We've got a chance to grow on the base that we've already built and to ensure that we move forwards rapidly and develop our capabilities here in the UK for not only the UK's good, but also as a contributor to a wider global market, a wider opportunity. By developing skills and capabilities now, by thinking about collaboration across the community, thinking about education, and thinking about constructing the infrastructure that we need, we have the opportunity to deliver the next generation of space systems by starting now. And so as to strengthen the UK's national security capability, we have to think about those threats that will be upon us in a decade and beyond. And the principal contribution of my office is to try to help to anticipate the future, to point to the direction of travel, and then to conduct experiments that allow us to figure out what will in fact be some of the potential solutions, and also, frankly, to dismiss, as science sometimes does, some of the things which turn out not to be so successful, and by doing so, to improve our understanding and our capabilities. The UK science and technology community has a long history of rising to apparently impossible challenges, of achieving several impossible things before breakfast, like Alice. And I think that we want to really exploit our unusually high level of intellectual contribution to this from the academic, from the startup, and from the government worlds to be able to take advantage of those skills that we already have to solve what most people would consider to be impossible challenges ever more frequently. And I actually feel very optimistic about our ability to do that. I'm confident that we'll continue to solve impossible challenges, and I'm confident that you are playing a part in a really important and worthwhile undertaking, which has, of course, direct bearing on defense and security, but which also has a much wider benefit to the nation and indeed to the world. And I think that we should all feel proud to be playing that part in this extremely challenging environment and these extremely complex problems. And I hope that you will all continue to feel optimistic about the journey that we have there. And I look forward to the chance to collaborate with you all as I continue in my post in supporting the UK's national security needs. Thank you very much for your time.
Alex, thank you very much indeed. That was fascinating. And we have a little bit of time for questions, so I will open the floor. It's really difficult to see. Tim.
Morning, Tim Robinson, Aerospace Magazine. What do you, with your horizon scanning hat on, what do you think is the most exciting space technology or kind of breakthrough on the horizon that we should be looking for?
So, you're asking me to choose between my children and predict the future. I think that there's so much evolution across so many different dimensions that I'm not sure I would be able to say one was more important than another. I am particularly astonished at how we've been able to lower launch cost, because that's so central to everything. And I think the commercial contribution of lowering launch cost is just of inestimable value, because that's not something that most people would have expected, a decade or two ago, but it transforms everything else. So that might sound a bit prosaic. That's not a sort of, bright, white, shiny technological answer, but actually, unless you can make launch cost accessible, you can't do anything else except at a sort of unaffordable or at least exquisite scale. So I think that's actually probably the single most important contribution to date. Your question was really about the, pointing all the way into the future. My particular interest is in the electromagnetic spectrum, in exploitation of spectrum, in what we can do to get more data through less spectrum and more insight from spectrum, and the advances in semiconductor technology, which are really central to that, and to signal processing technology, which are really central to that. Those are the two things which enable us to exploit those things. We've made extraordinary progress, and again, I continue to be surprised at how much more data gets crammed into smaller amounts of spectrum. And I think if we continue on the trajectory that we've been going on in the past for much longer, we're really going to crack some of the compelling problems in particularly areas that I mentioned earlier, like downlink, where being able to actually backhaul data back down to Earth is one of the most severe bottlenecks. But moving AI to the edge and actually doing more of the processing actually out on the platform also enables us to need less of that, and so we can sort of squeeze the balloon in more than one place. So I gave you several answers there, but actually I think they're all significant elements of the progress that we're making.
Alex, there's a question online here which may actually just elicit the same answer, but I'll ask it anyway. Where do you think the UK space industry needs to focus in order to facilitate the potential for the UK to become an active space contributor?
I actually think we need to focus more on the education and skills side of things. I think getting the next generation of people excited about their ability to participate in space is really important. I'm going to betray my age by admitting that I was a small child at the point at which the Americans were launching men onto the moon. And there was a huge program of public participation in that. My father subscribed me to some monthly magazine with models of rockets that would arrive in bits, and we'd assemble them on the dining table and admire them after we'd painted them. That sort of active engagement helps to stimulate people's interest, which can be lifelong. And I'd like to see us working harder to get all of the public excited about space, because by doing that, we maximize the number of people who can potentially then come and help us within, some of our perhaps narrower niches, such as defense and security, as well as working, more widely across the entire community.
Thank you. Can we take the question from here?
Good morning, Alex. Sean O'Connor. What do you think the defence and security community can learn in terms of horizon scanning from the entrepreneur and VC community that will allow us to spot those opportunities for disruptive advantage a bit further out than we're currently doing?
It's one of the reasons that I was happy to try to take on the work that I now do, coming from the venture capital background and before that the entrepreneurial background myself. It turns out there are a lot of similarities in the way horizon scanning needs to work in this kind of domain and in venture capital. When I was working for the last decade as a venture capitalist, we would typically see getting on for 1,000 incoming potential deals every year, and we would invest 4 or 5. So we had to have a system for bringing that funnel of potential deals down to the sort of distilled drops out of the bottom, and to do that on a daily basis. So you can do the maths. I'm seeing perhaps 4 or 5 business plans a day, and I'm probably actually personally engaging with perhaps half of those. So I'd be taking 1 or 2 meetings a day of an hour each with potentials. And then I'd be, frankly, trying to dismiss as many of them as possible, as quickly as possible. So, wrong topic, not interesting, don't like the people. It sounds a bit capricious, but actually, making judgments about whether entrepreneurs will be able to succeed is as much about their personality type as anything else. And that's no different whether they're space entrepreneurs or whether they're bioengineering entrepreneurs or whether they're quantum sensing entrepreneurs. They have to not only have the intellectual capability, they also have to have the personal characteristics, and then they have to have the money, and then they have to have the luck to be able to actually deliver success. So I think the systems can actually translate very directly from the investment environment. And one of the things that I've tried to do in my office is to build us an infrastructure which mimics the approach that we've taken. Very quickly survey very large numbers of plans, never forgetting that you learn something from every single submission, even if you don't choose to pursue it to, in my case, in the past, all the way to investment, now perhaps to exploitation. You learn something from all of them, and you can't afford to be ashamed about saying no to most of them. But in the end, there's a sort of 1% or less, hit rate in terms of selecting them, and that's where obviously the rubber actually hits the road, and we try and really get results. But the benefit of building the system that can cope with that kind of rate of incoming and still successfully do good investments or exploitation out the back, those are systems which we can absolutely translate across from VC, and I've already done that in my office. Thank you. Interesting question.
Yeah, down here.
Thanks. That's Paul from the Royal Air Force. In developing our conceptual capability, do you think that we need to focus exponentially and strategically on developing our AI and quantum scholars as other nations are doing now?
So clearly, artificial intelligence skills and quantum technologies and, for example, quantum computing skills are going to be really important to us. I'm not instantly clear what trying to exponentially scale them would be like. I think that the challenge is that these are very new, different domains which are not widely understood. So ultimately, the challenge comes back to the same point, which is about more people need to start understanding these things. I mean, sadly, there are probably as many people who will run away screaming if you mention artificial intelligence or quantum computing as will decide to engage with it. It turns out that I think I'm allowed to say as a relatively older person that it's quite hard to get one's head around these things if one didn't start by doing so. And one of the genuine benefits of younger, more plastic minds is that they actually build on the shoulders of giants. They start from a completely different place because they just assume that these things are understandable to them. They can be taught them, and they build on the, of course, thousands of years of scientific knowledge that we've all accumulated. So I think in that respect, perhaps it is naturally exponential, that when one educates the next generation, they get the benefit of everything that has gone before. But in terms of trying, perhaps I think you're referring more to the scaling of the numbers of those people or the amounts of money that we spend on doing so, it's very challenging for a nation of our scale to compete in any direct way numerically with the numbers of headcount or the numbers of pounds being spent on these things. On the other hand, I think there is a long and justifiable history in this country of us, as I mentioned before, being able to solve apparently impossible problems. It turns out that we're quite good. And in fact, some of you may not thank me for saying this, but actually there is an argument that less financing is actually more effective at getting better results. That we sometimes become a bit sort of soft and complacent because we can afford to do so many things at the same time. And actually the focus that comes with constraints can actually be quite compelling. That, of course, is the situation which usually pertains in war. One has to move very urgently in a very difficult environment with very constrained resources. And it turns out people often achieve actually more meaningful things as a result. So I'm quite interested in trying to impose artificial constraints on our ability to innovate as a device for helping us to actually be more creative.
I think there's time for one more.
Hi, Ali Ambrosiak from Tallers. I'm quite interested, you have obviously deep experience in startups and the venture capital space, but there are, as you can see from the sponsors on the screen, some companies who have huge scale in the space sector. I'd be really interested to understand where you think these system integrators and prime contractors fit into our ability to exploit the space capabilities in the UK, and how you would see them coming in and investing and bringing capability in to support our future needs.
Okay, fairly big question. The short answer is innovation these days generally isn't done in research and development labs of large corporations any longer. Those corporations, whether they're service providers or whether they're more specifically product vendors, tend to do their innovation by acquiring it. They tend to let startups do the innovating, let venture capitalists invest in those companies, which they're happy to do, and then acquire them. And venture capitalists and entrepreneurs are happy with that too, because that delivers economic results, but it also accumulates innovation into those larger enterprises. Just as an aside, that's a thing which government can't do. We can't acquire startups and merge them into the civil service. I might spend the next few years trying to find out how we can do that, but I think actually, that's an interesting conflict in the way in which the commercial domain works versus the government domain. And so I'm concerned with solving that problem from a government point of view, and I'm going to have to come up with some other kind of solution. So I think continuing to do that, continuing to acquire the intellectual capability and the economic capability into larger businesses like primes, it is actually the right thing to do. That's certainly the current mode. There is some evidence of a bit of a swing back towards building more robust R&D capabilities inside large organizations, but actually, the pull through, literally and figuratively, if you've got demand, whether it's demand to procure product or whether it's demand to acquire businesses from larger consumers, that's actually helpful in drawing everything else through the system. And it plays back all the way up the pipe to, people deciding to quit their jobs and start a startup and take their particular skills and exploit them economically. So I think I would simply encourage you to keep doing more of that, and in the meantime we'll work on finding a way to ensure that an analogous sort of solution is available to government.
Alex, I think we'll let you off the hook. You started 5 minutes early and we were bang on time, so you've overachieved. Thank you very much indeed. Ladies and gentlemen, please join me in thanking Alex.